Continuing on here, there are a lot of different ways that we can solve this equation. I'm going to go ahead and get common denominators on both sides and go from there. But you can simplify each side, you can multiply by the common denominator all the way through, lots of different options. But again, the first thing we want to do anytime we deal with fractions is to, anytime we're dealing with adding or subtracting with fractions, is to get a common denominator. So I'm going to go ahead and factor. This is a difference of squares. Multiply to 16, subtract to 0 gives me x minus 4, x plus 4. Difference of squares. So my denominators right now, I have x minus 4, x plus 4. I have just x minus 4. And then my 2 is over 1. Whole numbers are always over 1 in fraction form. So my common denominator then, each column here, gives me x minus 4, x plus 4. My least common denominator. Now I'm going to get each one of these terms to have a least common denominator that's the same. My first fraction already has all the pieces. My second fraction has the x minus 4, but needs the x plus 4. So I'm going to multiply by x plus 4. And if I change the denominator, I've got to change the numerator. My third fraction here doesn't have either, so it needs the x minus 4 and the x plus 4. Some of you guys didn't do this to both sides. Keep in mind, if we change one part of an equation, we have to change both. So if we change the left side, we have to change the right accordingly. Now what I can do is, since I have a common denominator here, I can write this as 16 minus 2 times x plus 4 over my least common denominator equals 2 times x plus 4, x minus 4 over my least common denominator. Now we can either multiply both sides by our least common denominator to get rid of it, or we can use cross products because we have a proportion. Doesn't matter. I'm going to get rid of my denominators. And because they're the same on both sides, those cancel, and all I'm left with are my numerators. So 16 minus 2 times x plus 4 equals 2 times x plus 4, x minus 4. And again, there's a lot of different ways you can do these. I'm just going to go through one, okay? I can think of probably 4 or 5 different ways just off the top of my head. But whatever works for you, go for it. If you're not sure, this is one way. Now that I don't have fractions anymore, we can just solve this equation. So I'm going to simplify both sides. Distribute on the left. FOIL first on the right, which is going to get me back to that x squared minus 16. Combine like terms. And distribute. I'm going to get it set equal to 0 because it's quadratic. Everything's even, so I'm going to take out that greatest common factor of 2. Now to multiply to 20, subtract to 1. It's going to give me x plus 5, x minus 4. Zero product property says the only way that works is if our factors are equal to 0, so x plus 5 equals 0, or x minus 4 equals 0, which means x could be negative 5, or x could be 4. Here we need to check our solutions though, because if I plug 4 into my original problem, I get division by 0. We can't have that, so x equals negative 5 is my solution. And again, once we get to here, it's just solving equations like we've been doing all year. So once we get rid of that fraction by multiplying by our common denominator, once both sides have a common denominator, it's just solving that quadratic equation like we've been doing for months now. I have this as number 6, so it's actually the first one from the chapter 9 quiz. And again, I'm only doing one set of the problems, so the ones you did might not be on here. But the same idea. So we want to know the 110th term of this sequence. First of all, we need to figure out what kind of sequence it is. Since here I go from -7 to 3 by adding 10, and then I add 10 and add 10. It's an arithmetic or arithmetic, either way, sequence, which means a of n equals our first term plus n minus 1 times our common difference. This plus 10 is our common difference. So we take our first term, and then we're going to figure out how many times we've added 10. It's always going to be one less than our term number because we didn't add it the first time. So we take our common difference, our change, times one less than our term number, plus where we started. So here, the amount of our 110th term is going to be where we started, plus our change. Our change is, well, 110 minus 1 times we took that common difference of 10. And when we simplify here, we get 1083. So the amount of our 110th term is 1083. Some of you tried to list all these out. That's one way. Takes you a whole lot longer. Doesn't necessarily fulfill the explanation part the same kind of way like if you were trying to teach somebody how to find it. But it gets you there as long as you don't mess up. There were a few of you who went from 523 to 543 or things like that. So just be careful there. But general idea here, by using the formula, gets us there a whole lot faster than counting them out. Okay, on this one, I messed up. I should have had 8 over 81 here, and some of you guys recognize that. Some of you guys just went based off what was there. I was pretty lenient on this one. Thankful for your videos so I could see what you were getting at and your rationale, and I kind of went with as long as you were on the right track based off how you took this problem. I counted it. So the way that it was written, it would have been neither, because it wouldn't have added the exact same thing or multiplied the exact same thing every time. It would not have had either of them, so this would have been non-existent. If I would have had the 8 over 81 here, which, again, sorry, when I do the checking on these, I know what I mean, so it's hard to catch little things like that. But we see that we multiply by the same thing every time. So since we're multiplying by the same thing, it would be geometric. Since it's geometric, it's going to have a common ratio. Ratio for multiplying. Common difference is if it's an arithmetic. If we're adding or subtracting, it's difference. If we're multiplying by that ratio, it's geometric. So here, our common ratio is going to be that 2 over 3. It's our change every time. We go from 1 to 2 to 4 to 8 to 16, 3 to 9 to 27 to 81 to 243. So again, I was very lenient on that one on your quiz when I graded it because I messed up. So as long as your reasoning for what you had was sound, I counted it. Here we're trying to find the sum of the finite series, which means it just ends. Finite just means it ends. Series means it's a bunch of things being added together. So we need to figure out how many terms are in this, because our formula for finding the sum of a series is going to be our number of terms divided by 2 times our first term and our last term. Okay, so the amount of our first term plus the amount of our last term times n divided by 2, which means we're just taking our average of those two terms times how many terms there are. Okay, the amount of our first plus our last divided by 2 gives us our average, and then we multiply by how many terms there are. So here we need to know, we have our first term, we have the amount of our last term, but we don't know how many terms there are. So in order to find that nth term, okay, we know the amount of our nth term is 59. Our first term is 29. It's n minus 1 times that common difference. And here we add 3 every time. So we're using our formula like we did on number 6, I believe it was, or the first one on here. Okay, that a of n equals a of 1, a sub 1 plus n minus 1 times our common difference. And we're going to solve for n here. So subtract 29. Add 3. And divide by 3. N equals 11. So we can plug in what we know. Our sum is going to be 11 divided by 2 times our first term plus last term. So again, it's the average of our first and last times how many times we did that, our term. So whether you write it this way, like our formula, or this way, like what it really means, doesn't matter. Here, we're going to get 484. In this one, we want summation notation, which means we're going to use our sigma. N equals 1 to how many terms are there? 14. We can set up that part right away. Now, we need our formula part to go in here. And in order to figure that out, we're going to figure out, because we're adding 5 every time, this is an arithmetic sequence. Series, sorry, because it ends, because we're talking 14 terms. So, I can take my first term plus n minus 1 times my common difference, and that gives me the amount of any term. Now, this I'm just going to simplify. Distribute. Combine like terms. And then I'm just going to write it in a standard form. You don't have to, but 5n plus 44. So the amount of any term is going to be 5n plus 44. So 5 times the term number plus 44. And that's what we want. We want it to start at 1. So we don't want to have to like take n minus 1 or anything like that. We want it to start at 1. So if I plug 1 in here, I get 49. If I plug 2 in here, I get 54. So it's a real quick check there to make sure. So again, the formula part that goes inside our summation notation here comes from our formula for an arithmetic sequence, our explicit formula. Here we want the sum of the first 7 terms, and this is going to be a geometric sequence because we're multiplying every time. And we can tell because our signs alternate. So our formula here for a geometric sequence is the sum of any term. It's going to be our first term times 1 minus our common ratio raised to our number of terms power divided by 1 minus our common ratio. Here, first term is 6. Our common ratio, we multiply by -4 every time. And our signs alternate, so don't forget that we need that -4. We want 7 terms. And again, our common ratio is -4. So our sum of the first 7 terms is going to be 6 times 1 minus -4 to the 7th power divided by 1 minus -4. Be very careful right here, guys. That -4 goes in parentheses because the sign there matters. Here it worked out either way, no matter how you did it, but it doesn't always. So depending on if your exponent is even or odd, you have to have that in parentheses. So here I get 1 minus negative 16,384. So I get 6 times 16,385 because 2 negatives make a positive. But again, if this would have been an even, we'd have had to subtract there. So be careful. Over 5. And the sum of 7 is going, the first 7 terms is going to be 19,662. So again, that's mostly just plugging into the formula. First term, our common ratio you did have to find and make sure it goes in parentheses. Term number came from there, our n value, and our common ratio here again. Again, I would encourage you to simplify first and then go from there. If you want to go even one step further here, you sure can. And those are the problems from the quizzes.